Hi everyone, how are we doing today? We're going to look at 2.7 today, which is all about graphing rational functions. So what we're doing is we're taking all of the information that we looked at in 2.6, right, which was finding vertical asymptotes and finding holes and finding horizontal asymptotes and finding the x-intercepts, right? We're going to add one more on today as well. But we're going to take all of that information and we're going to put it all together so that we can graph these functions. Okay, so our first objective is we're going to, let's hide this. Our first objective is to analyze and sketch graphs of rational functions. There we go. Okay, then we're going to sketch graphs of rational functions that have slant asymptotes. We have not learned about slant asymptotes yet, but we will get there. And then we're going to use rational functions. Actually, we're going to take that off. Sorry, I forgot last second that we were going to take that guy off. We're not going to do the word problem today. We're just going to look at how do we sketch these functions, okay? So I'm going to clear this and we're going to go down and we're going to look at this. What is the strategy for graphing these? And this is what we call the 6-step strategy, even though there is 7 steps, right? The 7th step is just to use the information to obtain the graph. We're just going to plot the information as we go, so we don't really need to use all the information at the end to graph it, okay? But this is what this is kind of the order that you're going to want to do, okay? First step is to find the y-intercept by plugging in 0, if there is one, right? If there's no y-intercept, that's fine. But you're going to plug in 0 to find the y-intercept. The second step is you're going to find the x-intercepts, okay, by finding, this says to set the function, or really just the top function, equal to 0 and solve. And so we'll look at that to find the x-intercepts, okay? Then we're going to find any holes in vertical asymptotes by factoring the bottom. Okay, remember that if something is a 0 of the top and the bottom, then that's a hole. But if something is a 0 of just the bottom, that's a vertical asymptote. Then we're going to find the horizontal asymptote, if there is one. Then we're going to by MD from Spotify. We're going to find the slant asymptote if there is one. And if there's a horizontal asymptote, there is no slant asymptote. And then we're going to plot at least one point between and beyond each x-intercept and vertical asymptote. So we need to be able to see what's happening on either side of every single horizontal asymptote and on either side of every single x-intercept. Oops, sorry. So let's just keep scrolling and we're just going to do, basically, it's just a bunch of practice problems today. What we got? 6 practice problems of just how do we graph all of this. So let's just start. It says sketch the graph of f of x equals 3 over x minus 2 by hand. Okay, so first step would be that we want to find f of 0, right? I want to plug in 0 and find my y-intercept. Okay, so that gives me 3 over 0 minus 2, so negative 3 over 2. So that tells me that my y-intercept is at the point 0, comma, negative 3 over 2, so negative 1.5. So 0, negative 1.5, so I'm going to plot that. Okay. The next thing that it asks me to do is to find the x-intercepts. Well, the x-intercepts is going to be anything that is a 0 of the top. So if I look here, what value can I plug in to make 3, 0? And there's no x here, so there's nothing to plug in. So this tells me that there's no x-intercept. So this graph does not cross the x-axis at all. Okay, the third step is to find any vertical asymptotes or holes. So let's start with our vertical asymptote, which is what value gives you 0 on the bottom. And in this case, the value that gets you 0 on the bottom is 2. Okay, and then the whole happens when there's a 0 on both the top and the bottom. In this case, there's no 0 on the top, so there cannot be a whole. So, no. So I found that there's a vertical asymptote here at 2. Okay, 4 is find the horizontal asymptote. In this case, this is x to the 1, and then on top is x to the 0. So in this case, my function is bottom heavy. It's bottom heavy, which if we look back on our notes, that means that there is a horizontal asymptote at 0. So I have a horizontal asymptote right here on the x-axis. Again, if there is a slant asymptote, there's usually not both a vertical asymptote and a slant asymptote. And we haven't talked about slant asymptote, so just take my word for it. There's none. Okay. And then the next thing is I need to know what's happening on either side of the vertical asymptotes. On to the left of the vertical asymptote, I have a point, so I can draw that. It's always going to approach your asymptotes. So I know what's happening there, something like that. I have no clue what's happening to the right of my asymptote, right? I could have a graph up here, or I could have a graph down here. So in order to find this, we're going to have to plug in a value to the right of this asymptote. Well, the asymptote's at 2, so I'm just going to plug in 3, but you can plug in anything to the right of 2. So this gets me 3 over 3 minus 1. Oh, sorry, minus 2. I was like, wait, that doesn't look right. So I'm just plugging 3 in for x, which gets me 3 over 1, which is 3. So I know that the point 1, 2, 3, 1, 2, 3, I know that that is a point on the graph, and therefore my graph is approaching the asymptotes up here. And the graph is always going to be approaching the asymptote, so it's always going to be something like this. And there's my graph, and I'm done. So step 7 was just to plot all that information, but we just plotted it as we went. So hopefully not too terrible. There is just a lot to remember here, right? Like, how do I find the y-intercept? How do I find the x-intercept? Which one's the whole, right? Stuff like that. So let's look at our next example here. And we're just going to continue to go through the steps. So step 1 is to find the y-intercept by plugging in 0. So f of 0 gets me 2 times 0 minus 1 over 0. Right here, I cannot have 0 on the bottom of a fraction, so this is undefined. And since I get undefined, that means that there's no y-intercept. So this graph does not cross the y-axis at all. That's okay. Okay, x-intercept is anything that is a 0 of the top, but not of the bottom. So if I set the top equal to 0, right, 2x minus 1 equals 0, add 1, divide by 2, okay, x equals 1/2. So this tells me that the graph crosses the x-axis at 1/2, 0. So I can go ahead and plot that point as well. Step 3 is to find any vertical asymptotes. So remember, the vertical asymptotes occur when the 0 is bottom. And so, when the bottom is 0. So the value here that gives me 0 on the bottom is 0. So that tells me I have a vertical asymptote on the y-axis, which makes sense, right? If I don't have a y-intercept, if the graph never crosses the y-axis, there's probably an asymptote there. And then for the whole, something that's a 0 of the top but not the bottom, well, the 0 of the top is 1/2, and the 0 of the bottom is 0, so there's no common number that's on the top and the bottom, so there's no whole. Step 4 is to find the horizontal asymptote. In this case, I have x to the 1 over x to the 1, so this is balanced. Since the equation is balanced, we just take our coefficients. So 2 on the top, 1 on the bottom. So I get 2 over 1. So I get y is equal to 2. So there's a horizontal asymptote here at 2. Okay, again, you're going to take my word that there is no slant asymptote. Okay, now here I know what's happening to the right of the asymptote, the vertical asymptote, excuse me, because of that point 1/2, 0. But I don't know what's happening to the left of this vertical asymptote. So I'm going to pick a point that's to the left of it, and I'm just going to pick -1 because it seems easy, right? And I'm just going to plug it in. So 2 times -1 minus 1 all over -1. So I get -2 minus 1, which is -3, over -1, which is 3. So that tells me at the point -1, I have a point at +3. And then I can graph it. Right? It's always going to approach the asymptotes here. And there's my graph. Okay, so this step 6 here, sometimes you might have to plug in more than one point to get what's going on, on the graph. But just know that you have to know what's going on either side of the asymptote and on either side of the x-intercepts. Okay, let's keep going. Let's try a couple more. Do one more together, and then I want you guys to try one. Okay. Personally, the first thing that I always do is I look to see if I can factor this. And in this case, I can, right? So I can factor x minus 2, x plus 1. If your factoring skills aren't super hot, this this unit and other units too are gonna get pretty challenging if you can't factor. Okay. So the first step is to find the y-intercept. So I'm gonna plug in 0. So f of 0 over 0 minus 2, which is 0 over -2, which is just 0. So that tells me that my y-intercept is at the point 0, 0, right there. Step 2 is to find the x-intercept. And the x-intercept is what values give you 0 on the top. Well, the only value that can give me 0 on the top is 0. So my x-intercept is also 0, 0, which I've already plotted. Third step is, what is my vertical asymptotes? So what values give me 0 on the bottom? And in this case, I actually have 2, right? +2 gives me 0 on the bottom, but also -1 gives me 0 on the bottom. And neither 2 nor -1 also give me a 0 on the top. So again, in this case, there's no hole. So this tells me I have a vertical asymptote here at 2 and a vertical asymptote at -1. Okay. We're going to keep going. We're going to see, can we find the horizontal asymptotes? In this case, I have x to the 1 and then x squared. So this function is bottom heavy. So since it's bottom heavy, y equals 0 is the equation. And this is where people get confused because they say, hey, how can the graph cross at 0, 0 if there's a horizontal asymptote there? And what happens is between two vertical asymptotes, your horizontal asymptote is invalid or can be crossed over. So the horizontal asymptote actually here only applies outside of the vertical asymptotes. As far as the slant asymptote, just take my word for it, there is none. Okay, now, excuse me, I have absolutely no clue what's happening to the left of this asymptote. I have no clue what's happening between the asymptote and this x-intercept. I have no clue what's happening between this x-intercept and the asymptote here at 2. And I have no clue what's happening to the right of this asymptote. So I'm going to have to start plugging in a lot of different numbers in order to find. So I just like to start on the left. So I'm going to plug in f of -2 because that will tell me where to graph to the left of the asymptote. So this gets me -2 on top over -2 squared is 4, minus -2 is +2, minus 2, which gets me -2 over 4, which is -1/2. So at -2, I have a point at -1/2. So this tells me that my graph is approaching the x or the asymptotes right below the x-axis. Okay, next one I'm going to plug in. I need to know what's happening between this asymptote and this x-intercept. So I'm going to plug in -0.5. Oops, I don't need that parenthesis. So that gives me -0.5 on top. -0.5 squared is positive 0.25 minus -0.5 minus 2. And when we do the math, we get 0.4. So almost 0.5. So at -1/2, it's at -4. -0.4, excuse me. Or positive 0.4. Wow, okay. So the graph is going up this way and approaching the asymptote. Okay, now I'm like, okay, I need to know what's going on between this x-intercept and this asymptote. So I'm going to plug in 1, just because it's an easy number to plug in. We get 1 over 1 squared is 1 minus 1 minus 2. I get 1 over -2, -1/2. So at 1, it's -1/2, so here. So the graph is approaching the asymptote towards -infinity. And then the last thing is I need to plug in a number to the right of this asymptote. So I'm going to plug in 3. And you can plug in any number to the right. You can plug in 20, right? I'm just trying to pick easy numbers. So that gives me 3 on the top. 3 squared is 9 minus 3 minus 2. And I get 3 over 4. So at 3, 1, 2, 3, I get 3/4. This is somewhere in here. And then that's really all I need to just draw my graph approaching the asymptotes. And there's my beautiful graph, right? So as I went, see, notice how many numbers I had to plug in, right? Because I had no idea what this graph looked like. So just make sure you pay attention to that. Okay, the last one here before we talk about slant asymptotes, I want you guys to try this. So start with factoring the top and the bottom, right? And then go through those 6 steps and see if you can graph this. If you mess up, that's fine. That's wonderful. Okay, at least you're trying. And then when you are ready to go over this, go ahead and hit play on your video. Okay, so hopefully we at least got as far as factoring, right? This top factors 2x minus 3 or x plus 3. And the bottom factors 2x minus 3, x plus 1. So I see that there's going to be a hole because I have the same factor on both the top and the bottom. So let's start with the y-intercept. If I plug in 0, I get 0 minus 9. So I'm using the original equation, and then 0 minus 0 minus 3. So I get negative 9 over negative 3, which is 3. So this tells me that I crossed the the y-axis at 0, 3. 0, 1, 2, 3. So there's a point. Great. Now for 2, I need to find my x-intercept. Remember, x-intercepts are anything that's a 0 of the top, but not of the bottom, right? So here, 3 is a 0 of the top, but it's also a 0 of the bottom, so it's not an x-intercept. Negative 3 is a 0 of the top, but not of the bottom, so that is an x-intercept. So negative 3 comma 0 is an x-intercept right there. Next thing is vertical asymptotes. Anything that's a 0 of the bottom, but not of the top. So in that case, I have one here at negative 1. So x equals negative 1. So there's my vertical asymptote. And then for the hole, I do have a 0 on both the top and the bottom, right? 3 and 3. So that does tell me that there's a hole at 3. I just have to find what the y value is of that. So what you do is you ignore these x minus 3's because that is what creates the hole. And so you just take your x plus 3, which is what's left over on the top, and your x plus 1, which is left over on the bottom, and you plug in your value 3. So I have 3 plus 3 over 3 plus 1, which is 6 over 4, which is 3 over 2. So I have a hole at 3, comma 1.5. So 1, 2, 3, right here. So that's an open circle. Okay? And you draw it as an open circle. I can probably do better. You could draw it as an open circle because we know that there is no value there. Yeah, there you go. Okay. Then we go on to the horizontal asymptote. Is this equation top heavy, bottom heavy, or balanced? In this case, it's balanced because it's x squared over x squared. You don't have to write balanced top heavy or bottom heavy, but if that helps you, then go ahead and do it, okay? So since it's balanced, I take the numbers in front, which is a 1 and a 1. So it's just the equation y equals 1. So here's the horizontal asymptote. There is no slant asymptote in this problem. And then for 6, I need to look at my graph to the right. I know that it's going towards my asymptote. And then here it's hitting that hole and then also going towards the asymptote. So I don't need any points to the right of the asymptote. And then I actually have this x-intercept, so I can approach my asymptotes there too. So I actually don't need any extra points in this problem, right? None needed, because the points that I found throughout the problem were good enough. Okay, hopefully we're feeling good here. If you have any questions on this, make sure you let me know. We have 2 more problems that we're going to do that involve slant asymptotes. So we're going to talk about slant asymptotes. And then we'll be able to put all of these steps together now that we'll know what slant asymptotes are. Okay, So slant asymptotes is exactly what you think. It's asymptotes that are at a slant like that, right? Or whatever. So you know that you have a slant asymptote if the degree of the top is 1 more than the degree of the bottom. So what we do is we, if you have like x to the third over x squared, right? Then that would have a slant asymptote. If you have like x to the fourth minus 2x plus 7 over x to the third plus 4x minus 3 or something, you would have a slant asymptote because the degree of the top is 4 and the degree of the bottom is 3. Okay, so what you do then if you have a slant asymptote is you just use synthetic division, and then whatever you get for the remainder, you just throw away. You don't need it. Okay, so you just use synthetic division, which I know that everybody loves, right? So in this case, the degree of the top is a 2, the degree of the bottom is a 1, so there is a slant asymptote. So I'm going to take my 0 of the bottom, which is 3, positive 3, right? Because it's the 0 of the bottom. And I'm going to write the coefficients of the numerator and just use synthetic division quickly. So bring down the 1, multiply, add, multiply, add. And in this case, right, I have a remainder of 2, well, I can just ignore that. And so the equation of the slant asymptote, right, it started with x squared, so this will be 1x minus 1. And that is the equation of my slant asymptote. And is that a line that we can graph? Yeah, you betcha, right? I know how to graph that line. So go ahead and find the equation of the slant asymptote for B, and then when you're ready to review it, just hit play. All right, so we have a slant asymptote here because the degree of the top is 2, the degree of bottom is 1. So I'm going to take my 0, which is negative 5, right? And I'm going to put the coefficients of my numerator there and just do a quick synthetic division. So multiply and add, and multiply and add. And whatever my remainder is, I'm going to ignore it. So the equation for this slant asymptote is 2x minus 11. And that's it. Okay, so we're going to take this skill and we are going to add it into our 6-step process so that we can graph more difficult functions. So same thing, can I factor? The answer is yes, right? X minus 2 on top, x plus 1 on top, and then x minus 1 on bottom. Okay, so first thing is my y-intercept. I'm going to plug in 0. So I have 0 minus 0 minus 2 over 0 minus 1. So we get negative 2 over negative 1. So my y-intercept is at 0, comma 2. So I'm going to plot that point. Okay, second step is my x-intercept, which are any zeros of the top that are not zeros of the bottom. So in this case, 2 is a 0 of the top and not of the bottom. So I have an x-intercept at 2, comma 0. But also negative 1 is a 0 of the top and not the bottom. So I actually have 2 x-intercepts here. One at 2, 0, and one at negative 1, 0. Third step is vertical asymptotes. In this case, the equation is top-heavy. And if we look in our notes, that would mean that there is no vertical asymptote. Here, I don't have any zeros that are common on both the top and the bottom. So I don't have a hole. We're going to go on to horizontal. Oh my goodness gracious, you guys, you have to yell at me. This is what I meant for my horizontal. Sorry. Horizontal was top heavy. So there's none. Not bad. Vertical, I get x equals 1, right? Because there's a 0 at the bottom. So here is my vertical asymptote. I'm sure you guys were like, what is this crazy lady talking about? Step 5 is there a slant asymptote? So now I'm going to look, the degree of the top is 1 more than the degree of the bottom. So yes, there is going to be a slant asymptote. So I'm going to take my 0 of the bottom, which is 1, and I'm going to divide it by the top by using synthetic division. So 1, add, 0, add. -2 is my remainder, but I don't care. So my slant asymptote here is y equals 1x, or just x, plus 0, which I don't need to write. So it's just the line y equals x, which is this perfectly diagonal line. Like that. And then the last thing is any extra points. So to the left of my vertical asymptote, I can tell that my graph is approaching my asymptotes, like so. And to the right of the vertical asymptote, I can also tell where my graph is approaching my asymptotes, like that. And there's my graph. Okay, so that is the graph of x squared minus x minus 2 over x minus 1. Go ahead and clear this. Last one I want you to do, so I want you to try this. So go ahead and hit pause on the video, go through the steps, see how you do, see where you need to be more careful next time, see where you need to make changes, right? So go ahead and give it a shot, and then when you're ready, hit play. Okay, so hopefully, let's check our work here, but hopefully we started with factoring. So this top factors into x minus 4, x minus 1, and oops, the bottom is just x. So I'm going to start with my y-intercept. Okay, y-intercept, I'm just going to plug in 0, and I get 0 minus 0 plus 4 over 0. Cannot have 0 on the bottom, so that is undefined, which means that there is no y-intercept. So the graph is not going to cross the y-axis. That probably means that there's an asymptote there. X-intercepts, anything that's a 0 of the top, but not of the bottom. So in this case, I have an x-intercept at positive 4, 0, and another one at 1, 0. So 1, 2, 3, 4, and then another one at 1. Okay. Third step is my vertical asymptotes. Anything that's a 0 of the bottom, but not of the top. The only thing that makes the bottom 0 is 0. So I have a horizontal or vertical asymptote at 0, which I kind of suspected since there was no y-intercept. Right? And then do I have any zeros that are common on both the top and the bottom? And the answer is no. So there's no holes. Okay, the next one is a horizontal asymptote. In this case, the equation is top heavy. So there's none, right? I don't have a horizontal asymptote. Slant asymptote, I do have because the top has a degree of 2 and the bottom has a degree of 1. So the 0 of the bottom is 0. So I'm going to take the coefficients of the top. There we go. And we're going to do synthetic division. So 0, and then add, and then 0, and then add, and then I get a remainder, but I don't care. So my slant asymptote is the equation y equals 1x minus 5. And that's something that I know how to graph, right? I start at 1, 2, 3, 4. I start at -5 and I go up 1 over 1. Or I can go down one to the left one. And there's my slant asymptote. And then the last thing is I have to decide, do I need any other points? So to the right of the vertical asymptote, I have two x-intercepts. But I know that I have to approach my asymptotes. So it's kind of weird. So what ends up happening is this comes down and then loops like that. Okay, because the end behavior has to be approaching the asymptotes. But I don't know what's going on to the left of this vertical asymptote. So I'm going to plug in -1 just to see what's going on, right? Is it going to be up here or is it going to be down here? So if I plug in -1, -1 squared is 1, minus -5 times -1 is +5, plus 4 over -1. So I get 6 plus 4, which is 10, over -1. So I get -10. So -1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And again, my end behavior has to approach the asymptote, so this probably loops around in some way as well. And something like that. And that's the sketch of my graph, right? Is it 100% perfect? No. But does it get the point across? Yeah, it does. Okay. And that's going to be it for us. We're not going to do the application problem on the next page, so don't worry about it. I just want to make sure that we're feeling very, very, very comfortable about graphing here. The next video that we're going to do, I'm going to go over a little like cheat sheet that we can fill out that's all about graphing. Right? How do you find the hole? How do you find the x-intercept? How do you find the y-intercept? How do you find the vertical asymptote? So it's just going to be a little like cheat sheet, step by step of how do you find each one of these things. Okay? If you need any questions, make sure you reach out and I'll see you soon.